Hello everyone, you are all welcome to lecture number 1237, and today's topic is heterocyclic chemistry and its definition as well as classification. So once we are talking heterocyclic chemistry means first we have to go to carbocyclic nucleus. So carbocyclic means whether it is 5-member or 6-member, they are all made up of only one type of atom, and that is called carbon. For example, if it is 5-member ring like this, so they are all made up of same atom like carbon. If it is 6-member ring like this, then it is all made up of only same type of atom, that is carbon. So if such type of ring is there, they are known as carbocyclic. But if one different atom is substituted in place of any of these carbon atom, they become hetero. Hetero means different and other than carbon. For example, if suppose compound is like that, means one carbon is replaced by oxygen, it has become hetero. Here again, if suppose one atom of carbon is replaced by another atom, different atom, that is oxygen, it became heterocyclic compound. So this is your carbocyclic and this is here heterocyclic. So the chemistry of heterocyclics is very interesting, because there are lot of, if I say lot, I mean thousands of compounds. They are heterocyclic and they have very important physiological and biochemical properties and importance. For example, pyrrole. Pyrrole is 5-membered heterocyclic compound, and that pyrrole is part of your hemoglobin. The red blood cell is the carrier of oxygen in your body. So like that, so many other compounds are there and they are playing very important physiological role. So I will be taking one by one. First, let me make it very clear that it is divided into two groups. First group is called 5-membered heterocyclic compounds like pyrrole, thiophene. Then second group of heterocyclic compounds are 6-member, that may be pyridine, then piperidine, so many alkaloidal compounds. And apart from that, sometimes the different atom means heteroatom, maybe not only one, 2 or 3 in one ring. So all possibilities are there, and different type of structures I will be discussing. I will give their structure and their properties, their preparation, and also some of their reactions. So here I have given some of the structures of heterocyclic compounds. Some are 5-membered and some are 6-membered. They are pyrrole, thiophene, furan, benzene, that is pyridine, and piperidine. And also I have given the structure of lactone. That is very important to understand. This is the structure of lactone, 6-member ring and 5-member ring. And this lactone is also heterocyclic, but it is not included in heterocyclic group of compounds. The reason is that it needs stability. Any heterocyclic compound which is not stable is not included in heterocyclic compounds. So that's why all lactone group of compounds, they are not included because they are unstable. So here, number one, heterocyclic compounds are relatively stable compounds. Unless it is stable, it is no more heterocyclic. It will go to lactone group, in which one or more carbon atom of the ring are elements other than carbon. So any element other than carbon, once it is substituted in the 5-member or 6-member group, it becomes heterocyclic. And these other atoms or elements are mostly oxygen, nitrogen, sulfur, phosphorus, silicon, boron and tin. Lactones are also heterocyclic compounds, but they are not included in heterocyclic grouping because of their stability. They are not stable compound, but they are generally excluded due to their instability of their ring system. Their ring system, whether it is 6-membered, 5-membered or 4-membered, is not stable. That's why they cannot be included. Number two, heterocyclic compounds may be designated after the heteroatom present. Thus, we have oxygen heterocyclic. Oxygen heterocyclic means it is designated on the basis of oxygen, and also its numbering will start from heteroatom, from here 1, 2, 3, 4, 5, like that. So the first 5-member heterocyclic compound is the furan, where one of the carbon is substituted by one heteroatom, that is oxygen. The second is nitrogen heterocyclic. In the case of nitrogen heterocyclic, we have very important compound that is called pyrrole, and I have already told you it is very important from physiological point of view, where one of the carbon is substituted by nitrogen in 5-member ring. Then the other one is, that is your 5-member ring, that is where one of the carbon is substituted by sulfur. Once it is substituted by sulfur, the name of that 5-membered heterocyclic compound is thiophene. Now come to 6-member. In 6-member, if it is aromatic ring and it is substituted by nitrogen, it is called pyridine. So here it is pyridine, it is aromatic ring, and one of the carbon is substituted by nitrogen. If it is not aromatic, just cyclohexane, where one carbon is substituted by nitrogen, it is called piperidine. And if 6-member, where one of the carbon is substituted by oxygen, then it is called pyrene. So in this way, these are all different type of heterocyclic compounds, and they are designated or named on the basis of heteroatom, and I will be discussing one by one their preparation and physical chemical properties. Very slowly, very slowly. Very slowly. On structure focus. So here number 3. The heterocyclic compounds may be classified on the basis of size of the ring of the heterocyclic compounds. For example, we have 5-member, means with 5 carbon, and maybe one heteroatom is substituted, and the compounds I have already given their structures. They are furan, pyrrole, thiophene, depends upon the type of heteroatom. Furan means oxygen heteroatom, pyrrole means nitrogen heteroatom, thiophene means sulfur heteroatom. And then again there are 6-membered heterocyclics, and they are pyridine, once nitrogen is the part of aromatic ring, piperidine, where nitrogen is the part of aliphatic 6-member ring, pyrene, and thiophene means again sulfur. Now number 4, again the 6-member rings and 5-member rings, sometimes they have more than 1, 2 or 3 heteroatoms. Then their names and structures are like that. Here first one, that is the 6-membered heterocyclics containing 2 or more heteroatoms. Number 1 6-member, where it is aromatic ring which contains 2 nitrogen, is called pyrimidine. And if the position of nitrogens are changed into ortho-ortho or para-para position, then it is called pyrazine. Then again the nitrogen is shifted to next one nitrogen, then it is called pyridine. So these are all 6-membered heterocyclics where more than 1 heteroatom is there. Now the 5-membered rings where there are more than 2 heteroatoms are there. Number 1, that is called imidazole, where 2 nitrogens are the part of 5-member ring. Second one, that is oxazole, where 1 is oxygen, other one is nitrogen. And then other one is pyrazole, where the position of 2 nitrogens are very close or adjacent. And the last one, that is 5-membered ring with more than 1 heteroatom, and they are also different. One is nitrogen, one is sulfur. It is called thiazole. So with this I will stop here, and now in the next lecture I am going to discuss about the nomenclature or naming of the heterocyclic compounds.